Welcome everybody to the fall 2023 Responsible AI Research Program Project Showcase. My name is Julia Stojanovic, and I'm really thrilled to see so many of you here today. I hope that more people will join as we progress through this 2.5-hour meeting. The structure of the meeting that several are going to give brief introductions for about minutes in total, and then we will dive into the work that you all have been doing. Next slide. The program that we are part of course, as you all know, is the Responsible AI Research Program that is a joint effort by many institutions, but primarily by New York University and Ukrainian Catholic University. Let's go to the next slide, and I'll continue with the overview. I'm Julia Stojanovic. I have the pleasure of running and coordinating this program together with Tanya and Yaroslav. I am an associate professor of computer science and engineering at NYU Tandon, associate professor of data science at the Center for Data Science, and I also direct the Center for Responsible AI at NYU, that is the host for this program. Let's go to the next slide. The center has a brand new website, and I'm taking this opportunity to do this little plug for the beautiful website that we have. You'll see all of our publications, and very soon there's going to also be an area dedicated to the program that we're discussing here today on this website. On the next slide, I'm going to discuss very briefly how this all started. So the RAI research program started last summer, in summer 22. We enrolled 18 students from universities in Ukraine who worked with 6 faculty mentors and 8 graduate student mentors from 5 institutions in the US and Western Europe. And we all worked on 8 projects. And I'm really happy to report that a lot of these projects have been successful. All of them have been successful because they were really lots of fun and we all learned a lot. But specifically in terms of deliverables that we can count, we were able to publish 3 research papers, 1 at FACT, 1 at VLDB that earned the Best Paper Runner-Up Award, and 1 at VizXAI. This is a Viz workshop, and I'm showcasing these papers here. On the next slide, this year, we have scaled up substantially, and we now have 14 research projects where 28 mentors from 12 institutions are working with 34 amazing research fellows from Ukraine. And some of you, of course, are continuing with us from last year, but the majority of you just joined us this semester, and it's really wonderful to see all the progress that you all have made. We will hear about all of these exciting projects today, and I know that there are also several papers being submitted for peer review in the January-February timeframe, and I'm looking forward to many more results in the near future. I also want to underscore that, of course, this program is really important to me personally, and I'm really happy to see it thrive. I'm really glad that we're using the terrible situation in Ukraine, the fact that Russia has attacked Ukraine for no reason that one can ever excuse, and yet we're using this tragedy to make sure that we don't stop, that we continue developing ourselves, that we continue developing international collaborations, and that we continue building research capacity in Ukraine through these collaborations. So thank you everybody for your heroic efforts despite the very adverse circumstances. And I'm going to hand over to Yaroslav. Next slide.
Thank you very much, Yulia. Hi, everyone. Indeed, I'm glad to see those who I seen last time at our presentations, but I also very glad to see very unknowns for me people. That means that we really grow in number and I hope in quality of what we do. Yulia mentioned the history of our collaboration and the scientific output that is already done. And I should say that we have plans, and we have big plans, and I hope together we'll be able to make them happening. They kind of have very different, not very different, but different vectors of development. So not only this research work, but also some work toward educating our pupils about responsible data science, about responsible AI, things to establish some to develop a center, research center at Ukrainian Catholic University. So many things to be happen in the future, and I hope today's presentation will show us that indeed it is worth to go further and to dig deeper in the area. Yulia, I would like to thank you, your team, all faculty you involve, all PhD students you involve in this, I should say, movement indeed, because your help and your responsible attitude toward this collaboration, it's something that we learn a lot about how to do research, how to provide such scientific service to our students. Thank you very much, and I wish everybody today to have great presentation and to convince everybody that it's already almost publishable result. Thank you very much.
So I would continue.
Now over to
Julia. Oh, please. Yeah, I will
Tanya.
continue. Can you hear me? Yeah. Yeah. Okay.
Yes,
okay.
we can.
We can.
So okay, great. I will join Yaroslav here, and I would like to thank you, you, Julia, and all the mentors for and all like people who would join and provide this really great program and opportunity for people inside Ukraine, especially for people who cannot go abroad to do research and definitely move forward. It's really valuable, and actually it was a really great time. I hope that everybody had fun, and it seems only that yesterday we just met for the first time with students and discuss how it will be going during this semester, and now I guess we are all ready to dive into our project presentations. So as a coordinator, I just will remind you that you will have only 5 minutes for your presentation, and respect the time for all teams, and have fun.
Let me also say maybe that some of the teams are a little bit larger, right? So the 5 minutes for
Yeah.
the presentation is for the teams that are 2 people. If your team is 3 people, you can take a little bit longer, let's say 7 minutes, and 4-person teams maybe up to 10 minutes, although we really ask you to keep it brief. If you can do 8 or 9, there will be an opportunity to ask questions, 1 or 2 questions after each presentation. And then at the end, I will also discuss a little bit the next steps for all of us here.
Great. So we can start with the first.
Do you hear me?
Yes.
Yes.
Okay, nice. Hi, everyone. Me, Katerina, and my partner, Alina. We are excited to present to you the project we've been working on for the last few months. People who supported us, gave us advice, provided us with help were our mentors, Joshua and Sakina from London School of Economics. We are thankful to collaborate with you guys and be a part of your team. So during our journey, our aim was to compare different model agnostic explanations and find their limitations, and in which cases they can potentially mislead us. Next slide, please. So I think first it would be nice to give you an idea of how to think about explainable AI. So what we want to do is to separate explanations from the model itself. For this, we can apply model agnostic explanations. They have a great flexibility over the model-specific methods as they are independent of the underlying machine learning model. Another alternative would be to use interpretable or intrinsic models, such as linear regression, but it has a big disadvantage that predictive performance is lost compared to other machine learning models. Also, we can talk about global and local explanations. And when we talk about causal inference methods, they aim to identify causal relationships, while IML methods are primarily employed to describe non-causal relationships. Next slide, please. Okay, so we started by exploring some of the model agnostic explanation methods, and then our task was to find cases that resemble real-world phenomena where produced explanations can mislead us. So we managed to work through scenarios of interaction, data dependence, confounding variable, reverse causality, and unused variable example. Also, during this, we discovered that not always high accuracy of the model implies the quality of the explanations. Next slide, please. So today we will discuss only post-hoc model agnostic explanations, partial dependence plot, individual conditional expectation, Shapley, and total dependence plot. Next slide, please. So PDP, ICE, and Shapley are non-causal methods. However, many people by mistake interpret the outcomes of this method causally, which can be inaccurate. We will not go into some math details how these methods work, but it's important to note that most IML methods show how the model's predictions depend on each feature, and precise meaning of depend varies based on each method, as in this case for PDP and Shapley. Next slide, please. Okay, so we can talk about TDP as the causal analog of PDP. This method also explains how a model's prediction depends on each feature, but in this case, we talk about causal dependence. And for those who are confused about what's the difference between causal dependence and dependence, so when we talk about dependence, we can think about the symmetry, but the causal dependence is not symmetric as it goes only in some particular direction. This is what causal methods, including TDP, try to capture.
Next slide, please. We made broad numbers of experiments with all those approaches and selected two the most representative. This first case depicts reversed causality features dependence, which is very hard to track, and it is a frequent problem in real-world datasets, as even domain knowledge may not always help to notice those bidirectional relationship between variables. In this example, we consider x1 and x2 as factors influencing the target variable y. However, our assumption deviates from the true data generating process, because in reality, x1 influences y and y itself influences x2. The example is with a random forest model, and despite being flexible, it completely misleads about x2 variable prediction. And this incorrect inference about x2 impacts to somewhat incorrect explanation of x1, but it is still preserved the major trend in the x1 explanations. Shapley values, on the contrary, have captured the variables' explanations flawlessly, just the same as TDP on the rightmost plot. Next slide, please. The next example features most common interaction type between variables. Our data has two variables, x1 and x2, and target y. It depends both on them. However, x1 affects y not only directly, but also indirectly via influencing x2. When one variable has the influence of this type, it is called backdoor effect. This effect is a real problem in explainable AI, as even the mere impact could completely mislead the variable values, creating false positive bias or even false negative cases when interpretability tools could not show the present bias. In this example, as we see on the plots, even the most robust TDP tool is not showing the exact features impact. However, it is a good overall approximation of the true dependence, and it is better than PDP or Shapley explanations for x1. So while PDP and Shapley capture x2 more precise than TDP, but the error is not so huge. And Shapley completely fails on the mediator variable x1, misleading about its value, and this particular example provides exactly opposite effect than the true dependence, and it would lead in the false positive bias in the real world case. To sum up, in general, PDP is a very inaccurate tool when data is dependent. Shapely values are better, but still often fail to represent true nature. TDP is much superior due to its causal interface. We could infer that causal algorithms are more precise than the non-causal ones. Next slide, please. With those conclusions made, in the future, we would like to explore the modification of causal Shapely and causal Lime tools. And those experiments could be combined in some tutorial for ML conference. As for more advanced approach, we could try to propose the improvement of those or other algorithms and or even propose the novel one and present the findings in the paper. That's all from us. Feel free to ask any questions. Thank you for your attention.
Thank you very much. Are there questions? Please just speak up.
I have one question. What data sets did you use for your experiments, or you just generated data and just from some distribution and employed those methods? And if it's just of some distribution, are you going to use those methods for any other real-world data sets?
Yes, as you previously mentioned, we used, so we generated the random variables, so constructed features and the target variable, because it's easier and we know the structural causal model, because when we work with real data, we don't know like the underlying patterns of it exactly. Yes, maybe we'll work with real world data, but this is not for now.
Okay, thanks.
I also have a question. How would you modify Shapely to make it causal? Do you have like an idea?
The causal Shapely is already exists and it uses the structural causal model. So this represents the graph which captures the dependence between different features. So given this structural causal model, we would know how every feature influences every other feature. So we haven't dived into their paper right now, but the approach is the same as in the TDP.
Thank you.
I have maybe like a weird question just on the motivation. If you have access to a causal model, why would you need an explanation method? Couldn't you just tell which feature affects which other feature?
I'm sorry, could you repeat? Our microphone was muted.
If you have access to a causal model, why would you need an explanation method? Couldn't you just read from the causal model which feature affects which other feature and which affects the downstream label?
So we have a structural causal model for the features in the data set, but not for the target variable itself. And we want to know what impacts target, not the features.
So let's move on. Thank you so much. Yeah, Roman,
Okay, can you hear me? Hi.
Yeah, we can.
Awesome. Hi everyone. Today I would like to present with Roman our work on a project with Lucius and Julia during this last semester, which is related to creating benchmark dataset for causal inference. Next slide, please. So to start with, what is causal inference for those who don't know? Causal inference is all about figuring out what causes what. Think of it like when you accidentally touch something hot and you immediately learn it hurts. That's causal learning in action. It's literally important not just for us, but also in the world of machine learning, so that we can understand why algorithms make the decisions they do. However, there is a fundamental problem of causal inference. Let's say you're preparing for a presentation. You can know what would happen if you prepped in advance and what would happen if you did not prepare in advance. You can only experience one of these scenarios, not both. This is what we call a counterfactual situation. So we can't really be certain about how a specific action or a choice, which we call individual treatment effect or IT, truly affects a person. To address the unknowns of what might have happened, we use SATA to compare average outcomes between treated and untreated groups. For individual variances, like how treatment might affect men and women individually, we use the conditional average treatment effect. Next slide, please.
Okay, so large language models, LLMs are far away from humans, and humans are far away from large language models. But in models, the generated output is caused by the variables in the prompt as well as with the humans. So the main feature of LLMs is that we can fix a seed, and imagine that a model with a single seed fixed is a unique individual. This allows us to generate counterfactuals by fixing the seeds and altering the prompt we give to the model. As with the humans, the individual treatment effect will alter from seed to seed as well because of the random noise, so we have to perform multiple experiments. And the perspectives of counterfactuals in model benchmarking include, well, post hoc methods, because large language models are large and they have billions of parameters, impossible to be explained by visualizing the parameters or other techniques. So therefore, we need post hoc methods to evaluate their stability and their reasoning. Counterfactuals generation is one of the ways in which we can estimate the sensitivity of the model to the changes in the prompt. A dataset with counterfactuals generated by an LLM is a nice alternative to manually generated academic datasets used for teaching purposes and benchmarking different approaches of estimating the treatment effects. Next slide, please. So our experimental pipeline. Our main approach was to master the example with running. So we define a runner, their age, fitness, health, and descriptors, so whether or not they are preparing for a race, or it is just a blank descriptor, or they dislike running. And we also define our treatment weather. It is either rainy and cold or sunny and warm, and also contains temperature from 32 to 59 degrees Fahrenheit for cold and rainy weather, and from 59 to 86 degrees for warm weather. The step is 9 degrees Fahrenheit. Outcomes of interest are the decision of model on whether to run today or not, and if the model decides to run, what would be the duration, distance, and the effort of the run. As a general architecture, we designed the pipeline to be experiment and model agnostic, so the whole code is reusable for any other experiment. To do so, we define the experiment via system prompt that describes the model who it is, prompt which asks for the outcomes and the possible covariates and treatments, which vary in each experiment. They all are used to obtain full prompts for every possible situation, and they're further fed into the model. The results or the outputs of the model are saved into a CSV file, and they're ready for analysis after some pre-processing to deal with inconsistent formatting. The text tab, well, the model used is Llama 2, which is open source and open for research purposes. It was deployed using Hugging Face Transformers library in 8-bit mode, so it was quantized. The experiments were held on NYU High Performance Computing Cluster on RTX 8000 Quadro GPUs. And the challenges include inconsistent formatting in model outputs, because, you know, they are stochastic, and even for a fixed seed, they can output something unpredictable. And another problem was the experiment stopping due to cluster job being ended on schedule before the experiment is finished. So we had to modify code so it logs the results. Also, somehow the results differed from GPU to GPU, possibly due to the differences in low precision 8-bit calculations in our models. Next slide, please.
Yeah, so we had kind of a challenge during, as Roman mentioned, with LLMs, is that sometimes there were inconsistent answers. Like, for example, it was even using emoji like Gen Z. And so that's why we had to create some preprocessing pipeline. Next slide. So that after you see like a data frame, we got 15 seeds, which is kind of 15 individuals, and which result, we got more than 18,000 rows of observations. And we had to make some preprocessing pipeline, and the result, we got clean and consistent data that we could work with and provide some insights. We got lots of insights, but we will share a bunch of them with you on the next slide. So we have plots. So we will start from the top one. So these plots are showing us the conditional average treatment effect of weather on how long and how far our model decided to run, and how it changes across different ages from 10 to up to 70 years. And looking at these box plots, we can see that the model was giving us relatively stable answers. And from the other below, we made a conclusion that actually any covariate can be a treatment, and we can estimate its effect. For example, even like you are preparing for marathon, it can also be a treatment for our model. And next slide. And moving forward, we saw that the more data we were generating, the more varied of outcomes we were getting, which is very interesting to work with and analyze. It was also great to see that the answers were logical. On the following plot, on the right one, you can see that as the distance was increasing, the duration answer of duration of a model was also tending to increase. So which is a logical relationship, like the more time you are running, probably the more distance you are running. Yeah. Next slide.
Yeah, so in future, we plan to include more experiments on primarily on decoy effect, priming, and framing, which are cognitive biases, and on fairness. Well, decoy effect, to sum up, is one of cognitive biases widely used in marketing when the client is proposed with 3 options, one of which appears as a loser variant, which changes the perception of other options. And we have real-world data from MIT students on which this experiment was carried out, and it was a real case by The Economist magazine. So it would be interesting to compare LLM answers with real human answers. Framing is a process when the way the question is asked influences the answer. We have some real-world data for this as well. It was based on reducing the voting age in Great Britain. And the priming is the idea that the exposure to one stimulus may influence a response to subsequent stimulus. So if you mention, for example, some sum like $10, it may affect the amount a person donates to you. So we plan to our experiment is already done. Well, it's the configuration is ready, but we have no data yet. So it will be targeted at a model deciding how much to donate to a charity fund with and without mentioning the initial sum, and seeing how it will influence the model. So it would be interesting to see and compare it to human. And also we may develop a benchmark for different models, because our experiment code minimizes the dependence on the model-specific interface. Thus, we are able to drop in replace current Llama 2 model with any other popular LLM, such as Mistral, YE, Starling, or Falcon 7B. This will let us compare models apples to apples and decide how useful our proposed ATE metrics are for estimating model fairness and stability. Next slide, please. Yeah.
Thank you so much. I guess we have no time for the question for you. If we will have like at the end, we'll give the space. Okay. Thank you so
please
much.
try to stay on time,
Yeah.
because if you run over by a minute or two, then we need to move to the next presentation.
Yeah, thank you. Artem, Svetoslav, are you ready? Svetoslav?
I think Liliana is talking, but she's on mute.
Oh, sorry. Yeah, sorry. Yeah, so first of all, we want to express our gratitude to our mentor for a really profound guidance during all of our research process. And our project was connected to real-world benchmarks for explainable GNN-based models. Next slide, please. So our main goal was to investigate the graph transformation from its starting form to another one. And MGNNs, monotonical graph neural networks, was one of the good versions to do this. And this can be really useful for graph complexion and also node classification for recommendation systems and so on. Next slide, please. So what is monotonic graph neural networks? This is the specialized class of GNNs, graph neural networks, designed to ensure that we will have really effective learning from the graph data, and also the ability to provide the symbolic explanation for their easier explanation to users, and to explain our prediction in a more real-world way. And the main thing is the completely equivalent MGNNs are really completely equivalent to data lock rules. Next slide, please. oh, it's not visible there. Okay, so yeah, data look rules often deal with complex relationships and dependencies. So the optimizing the rules to retrieve the data efficiently from the large data set while maintaining accuracy and minimizing computational overhead can be a really hard task. So what we are doing with MGNNs. Next slide, please. So first of all, we have to represent our data set as a graph to apply encoding. And this encoding will label all of the vertices with the numeric vectors to be able to proceed this with MGNNs. And also we will color all of the links between the nodes in different colors. Afterwards, we can process our graph with MGNNs, and last of all, we will decode this to show the resulting set of extracted rules. Next slide, please. So this is the example how our starting graph looks from and after encoding. So this graph represents just the simple way of family relations. For example, Kevin is the father of Mary, and he also has a brother, Tom, so the Tom is uncle to Mary. And to make other links between these three people, we can create this graph after encoding and use it with MGNNs. Next slide.
So our task was to find the possible benchmarks for our model for monotonic GNNs for the rule extraction. And here we will we had some filters for our data sets for our benchmarks. So first of all, we cannot use temporal graph data sets because they have a time component in them, and our architecture is not designed to work with time. Secondly, graph with one single predicate are not relevant for our dataset because the dataset only works, the model only works with datasets which have multiple predicates, and this is also necessary for data lock rules because data lock rules will have different the atoms in it and explainability. And also, we didn't use ontologies because description description logics in ontologies also restrict us in ways that data lock rules cannot express this logic, and that's why all data description logic is way more powerful in expression than data lock rule. And that's why, as data lock rules cannot express this logic, and monotonic neural network is equivalent to data lock rules, that's why monotonic neural network cannot learn such ontologies and data sets that are based on them. Next slide, please. Also, we tried to generate our graphs with LLMs, large language models. However, as you can see, this is the knowledge graph that was developed with the base of article of James Bond from Wikipedia. And the problem is that natural language is really noisy for knowledge graphs, and predicates and subjects should be cleaned and verified by some domain expert after any application and reasoning with data lock or MGNNs. Next slide, please. So we found family datasets, the datasets that had a natural way of expression, who is like a sibling to whom. And also we had an Wikipedia dataset with inference rules that is called InferWiki. And you can see here the metrics that was that our network learned and how the classification was done on ring prediction. Next slide, please. Speaking about ring prediction, here we have the rules that were extracted from the task of ring prediction. First of all, we need to discuss that chain rules cannot be learned from MGNNs because due to the design of the GNN, because a second multi-hop second hop neighborhood is not passed as by message passing to the network. And that's why variables are not visible on the second hop neighborhood. That's why chain rules cannot be learned. However, tree-shaped rules can be learned. And this is this is what the model is really powerful at. For example, we have the rule that is aunt, predicate is aunt, so aunt is somebody's sister, and also some sister also have by siblings sister is that aunt. Also, we can see that she has a father. Also, some interesting rules are symmetric rules. For example, somebody of x1 follows x2. However, x2 is followed by x1 on the left side, as we can see. And there are other atoms that were provided with InferWiki dataset that are specific to that kind of dataset. Next slide, please.
Node classification is another classical ML task with the goal to assign labels to the node based on the graph relationship, and our MGNN model is applicable for explanation of nodes classes. However, it requires some additional preprocessing modifications. It can be done by extracting the rules explanations for the unary replicates, like a kind of is type X. For example, our model can explain simple rules like trivial ones. Someone is someone's mother if it's mother of other instance. Easy one like someone is a father if someone else is his daughter, and also more complex one like three persons and daughter sister that was explained before. What's more, also our model extracts some bias rules. For example, X is wife if it has a son, and also X is mother if it has a husband. And now talking about our future plans on the next slide. First of all, we want to check alternative contents to make it playable for more datasets. Secondly, generalize the fact explanation algorithm for other model architectures. And the last one, to optimize the extraction algorithm to counter only most important contributions. Thank you for your attention. We'll be glad to answer your questions.
Thank you so much. Maybe we have some, like one question. Okay, so let's move on. Thank you so much.
Okay, so let me start. I'd like to present our research in graph pattern matching inquiry languages with mentors Leonid, Emily, and Christina, and Alexander and me as research fellows. Okay, next slide, please. So our main goal is to translate a query from graph database into relational databases. We took Neo4j and Cypher as a reference in graph databases and Postgres as for relational databases, and our goal was to write like automated translator that can translate queries from one pattern into another. Next slide, please. So for the SQL, we took 6NF representation. It's a bit academic stuff. So we present our graph as only unary and binary relations. You can see here, so we have node IDs, edge IDs, then binary relation source and target that identify node for each edge, like being source and target. Then for labels, unary relations, and also for properties like ID of edge or node and the value. Yeah. Next slide, please. So this is an example. We have Cypher query here, and we have a pattern in our own grammar. It is like similar to Cypher because we took like a sub grammar of Cypher, not to overcomplicate and do it like step by step, increase the difficulty of our queries. Next slide, please. And so for the parsing, we use Antler. So we take the cipher, we like translate manually into our grammar, and then we write program. It uses Antler. This is like a framework that builds this parsing tree, and then we do the traversal of this tree and generate SQL query that is identical to this cipher query. And now I give floor to Alexander, please.
As you can see here, we developed the first version of our converter for graph pattern matching grammar to SQL in 6 normal form. The main idea under this converter is processing the pattern tree that's shown on the previous slide and representing the tree structure in SQL form with respect to the relational database structure. It's a bit big query in result, especially when we compare this with the original pattern query. But this approach allows us to represent the whole structure and provide readable, human-readable results for SQL query. Let's take a look on one more example. Next slide, please. Yeah, the second example we want to consider is recursive query. It's kind of one of the hardest structure to convert to SQL form, specifically for this a lot of kind of uncertainty in recursive processing. Here you see the example in Cypher Neo4j language. Neo4j are one of our databases to do in benchmark and comparing the result, and this query translated to our grammar form. And let's take a look on the SQL representation. Next slide, please. Here you see even more longer SQL query. It's a recursive query representation in 6 normal form. It's kind of similar to the previous one. We still represent the tree structure, but in this case we need to use a recursive processing of PostgreSQL to be able to get all passes, to collect all passes and obtain the same result as in graph database. Next slide, please. Yeah. For our first result, we provide a simple benchmark. For the benchmark tool, we choose LDBC framework. It's a commonly used benchmark to test the various functionalities of system that use the graph-like data. And for this first evaluation part, we took the dataset with scale factor 0.1. It's about 300,000 of nodes and 1.5 million edges. And as kindly expected, we see that Neo4j performs at least twice better and even more for recursive queries than PostgreSQL. At this stage, our SQL queries are not fully optimized, and it's more than expected. Next slide, please. As a future steps, we consider to finish our query translator to full support the recursive patterns and optimize the result SQL to improve the performance of this, and also comparing the results with GQL and SQL PGQ dialects, which are specific dialects to work with graph representation in SQL, and complete the benchmarking this LDBC dataset with different scale factor and make it like perfect result. Actually, that's it. Next slide. We thank you for the attention and happy to answer your question if you have.
Thank you so much. We have time for the one question.
Yeah, I have one question about benchmarking. How do you conduct benchmarking? So you run Cypher queries on Neo4j engine and SQL queries on Postgres SQL engine, right? Because Neo4j it's in memory database and Postgres it's not in memory database. And for me, it's question how you can correctly compare execution of these two types on these two types of engines.
Yeah, you're right. It's mostly comparing different engines, and for now, it's comparing the result of running queries without like proper benchmark methodology. We avoiding cold start problem to have some predefined cache, but then we run these queries on the same DS and compare result. For the future plans, we want to fully use the methodology described for this LDBC benchmark, which completely orientated for the graph database, including Neo4j, and they have described methodology to run tests on Neo4j as well, and Postgres.
Okay, thanks.
Thank you. Let's go.
So,
Madam Anastasia.
yeah, I will start, and I'd like to present you our project related to bias detection in social media that we managed to do in cooperation with our mentors, Mikola and George. So we would like to thank our mentor for the constant support and for the freedom in choosing the direction of investigation. And let's try to define how we managed to cope with this task on the next slide, Tatiana. So yeah, our three main ideas are bias detection, adversarial attacks, and continuous learning. We managed to combine it, and I would like to explain you what does it mean, every of three components. So the bias refers to an algorithm's tendency, and you can see the bias in UN media when we see some harmful tendency in texts and failures. And adversarial attack, it's a manipulating of input data in order to fool the model and fool the model perceiving of the data. And continuous learning, it's an ongoing process on machine learning model training in order to adapt the data to new challenges and new data and make the model more robust. So how we managed to cope these three at first glance very incompatible ideas, we can see on the next slide. We've started with bias detection, and we've tried to create some method to separate censor of the whole article and then investigate how the separate sentences and separate words influence on the model perceiving of it, of the label detection, and etc. So we separate the article into sentences, then applied some transformer models. We were working with Berta mostly from Hugging Face library, and then based on such attention weight scores, we've decided which sentence contribute to the model perceiving the most and trying to modify them. So that we created some two models and combine them. First, the fake model detection and then the classification of label decision. And then we also modificate our fakeness model with some weight modification. You can go to the next slide, Tana. We got to adversarial attack, and we were trying to improve the model resilience to this adversarial attack. So we've investigated how these adversarial attacks can harm the model. We've conducted a control attack retrain cycle in order to train the ability of the model to resist similar attacks in the future. And we've gained some very interesting scores about, nevertheless, the attacks were very simple, but yeah, we've involved such A and B adversarial attack and trying to compare them. And then we go to the combination of this method. Next slide, Bogdan, you're welcome.
Yeah, I'll continue. So what do we have? First of all, we have continuous learning and have model our model that retrains and so on, and have the attacker, if, for example, that applies attacks in time. And the interesting question is there any dependency between attack success and time? I mean, if we fine-tune the model, if we, for example, use model in continuous learning, does attack success, does model become more vulnerable or less vulnerable, or doesn't change? And we got interesting results that in some cases on some datasets, so, for example, we use dataset A racial bias for racial bias classification, B for gender bias classification, and fine-tuning on A then B, we got interesting results that if you just fine-tune on B, if you see we compare fine-tune on A and then B, F1 score increases. So the model becomes more accurate, better model. And interesting that this data set was in paper MBAB, and the results was lower because they just used one data set. They didn't use transfer learning. But interesting results that attack success rate increases. So the model becomes more vulnerable. And it proposes a question that, so for example, we fine-tune the model, we train it, it did become better in continuous learning, but it also could become more vulnerable to such an attacks. And next, please. So our solution is like, for example, first we train usual model. It could be BERT, Roberta, or something like else for classification, like in the upper part. In the lower part, we have model that we train to detect just we created data sets of attacked, not attacked examples by the method, and we trained another model to detect such an attacks. Then we concat last layers at FNN, and that then we have final like bias unbiased prediction. Then we froze second model and fine-tune this model and have kind of robust architecture. Next. So if in a previous slide, you mentioned that we combine two models. One model for simple prediction, next for detecting the attack, and then the combination is much more robust to the usual attacks than simple first model. And where we can apply it, for example, multiple attack scenario when we have political parties or something like that. And for example, party A wants to post fake news about the party B and apply several attacks. And our approach is for gather these attacks, create united data sets, fine-tune train second model, attack method classification model that gives tips to the first model through that architecture. And thus we have much more robust model that could not only like predict, but also detect and attack and then predict. Next, please. If we use just one attack scenario, we have different like goals, and we also will contribute in the future to these goals. The first is like fast news detection, just detects or biased or fake news. Then we try to detect like selection bias as a reporting bias. So we like need first solve task one. We need to robustly detect such an attack, and then we create robust model that doesn't change true label, even so it is attacked, but some attack method, and then solve task 2 and task 3. And by the way, the attack method is like a popular method that changes phrases or changes exact words based on the importance to the prediction, and try like find the exact substitutions that will change the score the most. Next, please. So about conclusions, first we developed like a new approach, because usual computational methods are usual attacks very computation expensive, and we couldn't even like attack big data sets if articles was even abzats long, several sentences long, like separating each sentence and then attacking separate based on the importance to the prediction. Then we used like explored continuous learning with combination to adversarial attack and bias and fake news detection, like intersection and methods of attacking and defending. And then we proposed our architecture that combines several like assembly models for more robust prediction, more robust detection of bias. So it even could be attacked, but it's much more robust. And in future, we plan to more like spend time developing, testing on different data sets, developing maybe a modified version of attack, because the more advanced attack is, the more our second model is like clever, and exploring new topics in this area. Thank you.
Thank you so much. Maybe really one short question. Okay, let's move on. Thank you.
Hi all. So we present to you a learnable SQL random query generator. This, please next slide. This random SQL query generator is produces syntactically and semantically correct queries. Its applications include feature and performance testing of SQL languages, portability evaluation, finding implementation bugs, and model fitting. As a matter of fact, during the course of our project, we were able to successfully create pull requests for the SQL parser we have been using under the hood by utilizing the debugging powers of the generator we have built. Next slide.
Now let's discuss key features of our random query generator. First of all, it can be easily extended to different SQL dialects. We can also guarantee that it always produces syntactically and semantically correct queries. Our generator is learnable, which means that it can learn from different workloads and mimic them. It's also schema agnostic, which means the generator adapts to a given schema. Our generator appeared to be pretty fast. We measured, and it produces queries at average speed of 87,000 tokens per second. Next slide, please.
To facilitate query generation, we have created a decision graph. This decision graph is quite big, but without any repetitions, which is because the purpose of this graph is to make every SQL query correspond to a single graph traversal and every graph traversal to correspond to a single SQL query. On the right, you can see a simplified version of a section of our graph, which contains query generation subgraph on the right and from clause generation subgraph on the left, here only with Cartesian products. Query generation happens by the traversal of this graph. Furthermore, edges of this graph possess probabilities, facilitating the generation process that can be learned from query log workloads. Finally, as you can see on the right, the graph is split into multiple extensible and modifiable modules, which allows us to avoid any repetitions. And the graph structure further helps us to make the generator easily adaptable to any SQL dialect or a language subset. Fun fact, to encode this decision graph, we have created a mini programming language based on dots, featuring functions, variables, branching, and function arguments. Next slide.
Let's move on to query validity. As mentioned earlier, the generator produces only syntactically and semantically correct queries. Invalid nodes are pruned in accordance with specific database schema, types, and generation contexts. In the picture on the right, illustrates one of those cases where obviously adding a string a to an integer value 3 is semantically incorrect. Thus, the node which corresponds to the string value is purged, thereby avoiding a type mismatch. Next slide, please.
As a matter of fact, let's compare our generator to one of the most popular open source random SQL generators in the field, skillsmith. In the past, skillsmith has successfully found bugs in PostgreSQL and has numerous forks for other projects. If you compare our approach to skillsmith, we'll see some significant advantages, which includes decision graph logic, which unlike production role-based generation does not depend on the AST and generates queries in the left to right way. Dead-end avoidance versus dead-end backtracking, which speeds up the generation process. Complete semantic error avoidance by pruning of invalid nodes versus error avoidance by trial and error, which means that we don't need to run the generated queries on a backend to generate valid queries. With all that, a comparable speed of 87,000 tokens per second versus 106,000 tokens per second using an NLTK tokenizer. And finally, the ability to train on a given query workload instead of having to specify specific production rules and constraints, which adds flexibility to our generator, combined with the ability to plug in any machine learning model to facilitate generation, ensuring wide applicability in the field. Next slide. Finally, let's discuss applicability in the field. The open source query generator we have created can be heavily utilized. For example, we found two papers, one where GANs were utilized to create syntactically correct queries, and one where recurrent neural networks were combined with reinforcement learning to generate random queries under some specific constraints for performance testing. Both of these studies can benefit by utilizing our generator, allowing them to achieve significantly greater expressivity and avoid bugs unrelated to the model that they actually train. As it's quite hard to generate a query generator from scratch, we believe that the future work will vastly benefit from this contribution. Next slide. Thanks a lot for your attention. If you have any questions, please ask.
I have a quick comment. Yes, I have a quick comment, and that is that the two of you, Alexander and Mikhailo, have been with us since the beginning of the program, right? And it really shows you've practiced giving these presentations quite a number of times, and it's just so, punchy and streamlined. Congrats.
Thanks.
I have one question about, do you have any plans to train a model to enhance your query generator? Or just interested in how they want to apply machine learning here?
Yes, of course. Actually, it's easy to plug in any model into our generator, because we generate states left to right, and we basically can create any model that generates states into this architecture. So yeah, we'll be potentially testing this, but this will be in the paper.
Thank you.
Can I start?
Yeah, for sure.
Thank you. Hi, my name is Uliana, and I, with Olga and Matvey, last month work on the project Close Reading of Relational and Knowledge Graphs. We want also to say thank you for our mentor, George, for his support in this project. In our project, we developed the first methodology for closed data readings of knowledge graphs. Next slide, please. Nowadays, information systems play a significant role in various aspects of our lives. Structuring information in these systems require careful consideration, as it can have lasting impacts on individuals and communities. Critical data modeling bridges technical system and social factors, promoting the creation of fair and more equitable information systems. Next slide, please. To ensure ethical and inclusive information systems, before diving into critical data modeling, it's essential to closely examine the entity relationship schemas and perform the closed data reading of it. Despite potential drawbacks, biases in data modeling can also shed light on societal values. Currently, there is a lack of a standardized method for this closed data readings of entity relationship schemas. To bridge this gap, we have developed the first methodology, and Matvey will present it. Next slide, please.
So yeah, let me introduce to this first ever methodology on the closed data reading. It contains, as you can see, branches for model and data-driven approaches. And note that those steps and branches can be easily interchanged, or the minor changes to the order can be applied. But the main takeout is that this is a pipeline. So you take an input from the previous step, process it in some way, and provide the output for the next stages. So thus the work keeps managed, organized, and can be easily scaled. Since the information is better perceived with an example, I would provide a short one. So firstly, we decided to take the Research Institute schema and explore it a little bit further. So pay attention to the perform EDA step, and let's move on to the next slide. So yeah, when exploring the Research Institute data schema, we saw that there was no information about the gender distribution of the researchers. So we looked into other schemas, and we didn't find this information either. Therefore, we decided to take the data-driven approach and found this information in data. And it turned out to be disproportional. And so we decided to explore it further and found out that it differs among different countries. Thus, we decided to access the geographical distribution of the data, which you can see now. And for now, this offers us the crucial insights into the scientific landscape, allowing for an understanding of the efforts and scientific development across countries and region. This can also create another source for bias in our Research Institute schema. So this is basically the distribution of the how one step can influence our research and how we perform it. So the next steps will be described by Olga, please.
Next slide, please. After analyzing all the data available, we can identify potential biases. Before acknowledging them, it's crucial to explore some entities connected to your schema. In our case, 3 potential biases include gender, employee gender equality, geographical factors, and funding. Next slide, please. Moving on to the next step, let's focus on a single, possibly the most significant bias in our analysis is simply gender equality. By examining this map on the slide, it becomes evident that the percentage of women in research is disproportionately small. And at this stage, it is essential to understand the reasons behind the appearance of this bias. Next step, please. In conclusion, we should draw insights and propose ways to remove bias or reduce its impact. However, it is important to note that complete bias elimination is probably impossible. Next slide, please. And here are some helpful techniques to consider during your reading. First is the 5 whys method, where you ask why repeatedly until you identify the root cause of the problem. But remember to stop when responses become unhelpful. And alternatively, you can use brainstorm and seek assistance from others to uncover potential biases. Next slide, please. And finally, our future plans involve considering relational data models, conducting a group close reading to observe variation, and testing our methodology on readers with diverse occupation to collect feedbacks. If you're interested to be our first experiment, please feel free to contact us. And thank you for your attention. And if you have any questions, we would be happy to answer.
Thank you so much. Do you have questions? Volunteers to join this project? No? So let's move on. Thank you so much.
Hi everyone. So first of all, together with Nazar and Denise, we are immensely thankful to our supervisors, Fala and Julia, whose expert guidance has steered us through numerous challenges. So our team was working on incorporating stability into the design of data-intensive pipelines. And next slide, please. And our project objectives was draw the differences between model stability and model uncertainty, and conduct experiments with different fairness interventions to demonstrate the connection between accuracy, uncertainty, stability, and fairness, and to develop a practical tool for responsible reporting that incorporates overall and disparity model performance dimensions. Next slide, please. So one of our direction was an exploration of learning fair representations, or LFR. And the goal of LFR is simple, just to create a representation of data that encodes information effectively while hiding details about certain protected attributes. And an objective function of LFR, there are 3 parameters that affects preprocessing, and they are responsible for statistical parity, information loss, and prediction accuracy. And next slide, please. And the problem we faced that LFR is not applicable to each dataset with default parameters, so we've developed pipeline to tune parameters, considering different metrics to pick the best setting. And we integrated LFR into our fairness variance pipeline, and we used Virney framework to display metrics. And next slide, please. And when we run the full fairness variance pipeline with both LFR and another technique called disparate impact remover for student performance dataset, we found some interesting insights and described it in our report. Nazar, you're welcome.
Yeah, next slide, please. Another fairness intervention technique we used is equalized odds post-processor. It modifies predictions of any given classifier to meet equalized odds criteria, or more relaxed one like equal opportunity. And the main goal is to construct the right predictor that minimizes the expected loss between ground truth labels and post-process predictions, using joint distributions of predictions, protected attribute, and ground truth values. The algorithm finds the optimal solution for the objective function, which is a set of probabilities with which we flip predictions to equalize the odds of being correctly or incorrectly classified for both privileged and unprivileged groups. Next slide, please. For our experiments, we use 3 datasets: credit card clients, law school and folk tables, ACS income task. And to measure variation in post-processor output, we use Bootstrap procedure to construct an approximate ensemble with 200 members and 80% fraction of training dataset for each member. Each model is trained using the optimized hyperparameter settings of the base model, and after training the model on subset, we feed post-processor on obtained binary predictions and evaluate it on test set. Next slide, please. Yeah, and for all three datasets we evaluate, the impact of fairness post-processing on accuracy is negligible. This means that we get models that are comparable in accuracy, but different on other properties such as fairness. And as we can see from lower plot, that our post-processing leads to reduction in error rate disparities across all datasets. Yeah, next slide is Denise.
Yeah, the next part is about interactive app for responsible reporting. So this tool serves as a visualization component within our Virne model profiling library, empowering data scientists to engage in responsible model selection and nutritional label generation for their models. The application comprises 6 screens, and on the slide you can see one of them, where users have the flexibility to interactively choose a specific combination of models, overall metrics, and disparity metrics to generate a corresponding visualization for analysis. Next slide. Our tool is developed with a user-friendly flow design, specifically tailored to guide users through a responsible model selection process. The flow includes 6 steps, and on the slide you can see 4 of them. And so the first step is to analyze demographic composition of the dataset, just proportions and base rates for different protected groups. The second step is to reduce the number of models to compare based on overall and disparity constraints. The third and fourth steps are to compare the selected models that satisfy all constraints from the previous step and compare them using overall and disparity metric heat maps. And next slide. The fifth step is to break down the performance of the selected one selected model concerning multiple protected groups and performance dimensions. And finally, the sixth step is to generate a nutritional label for the most optimal model. Next slide. Building upon the progress achieved in the past 3 months, our aim is to finalize 2 research papers. One is a demo for Sigmod, and another is a paper for ICML. Regarding the Sigmod demo, all the practical work is completed, and the draft is currently in progress. As for the ICML paper, our next step involved conducting 2 types of experiments. Firstly, we want to execute experiments involving another preprocessing inference intervention, specifically optimized preprocessing on 4 tabular datasets in use in our research. And secondly, we intend to conduct experiments with a neural network using a computer vision dataset, and we will experiment with 2 state-of-the-art approaches for fair image classification, specifically with fair batch and fair mixup. Next slide. Thank you for your attention, and we are very welcome to your questions.
We have time, at least for 2 questions. So thank you for this.
I can ask a question. What did you enjoy the most and the least about the work?
I can't say about myself. I'm on this program from the last year, and during the last year, I developed our library, which is Virne, and based on that, we conduct our experiments. For me, it's a pleasure that initial architecture of Virne is quite good, so it's quite extendable for other data sets, other models, and we still use it. So it's good things that you can develop previously and people use over time, and it's still live. Yeah. And another thing, I would say one more, maybe other guys also tell, it was interesting that everybody of us invested a lot of time in this project, and we had interesting discussions. So it was just interesting to see the progress of all of us as a team. So yeah.
I personally most enjoyed working with the peers, and the last one is setting up environment in cluster. It's a quite mess.
Yeah, it was a really great experience to work in such a great team. And one more thing, I really like to ask lots of questions in Nazar and Denise. So yeah, thank you.
Great. So let's move on. And
Yeah, let's do one more and then we'll take a break.
Yeah,
Yeah. Right after this one.
Yeah, hi everyone. Do you hear me?
Yeah.
Yeah, great. My name is Victoria. I was working with Alexandro on Synergy projects this semester, and we are from Ukrainian Catholic University. Our mentors are Luca, Julia, and Bill, who provided us with constant support throughout the entire program, and we are really grateful for this experience. Next slide. Let's talk about the project, and the main concept of our project is differential privacy, which actually has a great idea behind it. It was introduced in 2006, and according to its definition, the presence or absence of any individual record in the dataset should not significantly affect the outcome of the mechanism, because the mechanism, any computations that can be performed on the dataset, thus it's hard to tell whether someone is present on the data or not. Next slide, please. If you look, if you look at the examples, then on top we have our true data, and to make it differentially private, we add the noise, which ensures that individual's information is basically not disclosed. Next slide, and still it has the same insights as our true data, and the distribution of the true data is also preserved, not just independently, but also in a two-way correlations.
Next slide, please. Synergy is a benchmark which shows how good are the existing differentially private synthesizers for real-world use cases. The dataset is selected and paper related to it are analyzed. Then the findings are extracted and implemented in computable way. After that, we can run different synthesizers using different random seed and then compute the proportion of trials in which the findings has hold for synthetic data. This way, we get the value of epistemic parity for every synthesizer and every finding. Next slide, please. We started our work on the project from code improvement, cleanup, documentation for every available synthesizer, extending parameters list for our implementation to be same as in original synthesizers. We also implemented a way to configure synthesizers with both named parameters and dictionary to provide suitable for any purposes API. In order to help any new users to use the benchmark, we added example notebooks to the code base. Next slide, please.
Here is the video, but the most but the most exciting thing here we were working on was the documentation website, which is actually a real great starting point for any user who is exploring our benchmark for the first time. Is it available to turn on? Like this should be.
I can, but I'm not sure with the sound. Do you need sound?
No, I don't need any sound. Yeah, I will comment on the road. Yeah, to show some of its content, we have a quick start page where there is information about how to install our benchmark, set up additional dependencies, and also explore more about the structure of the package itself and how to add, for example, new papers. On top, we have also the GitHub repository and the option to configure website theme, and the Python API page serves as a place where the user can find example notebooks on how to work with our benchmark, as well as the documentation for each data synthesizer, including the description of the parameters and the source code for it. And Sasha will talk more about the findings page that we're working on.
Next slide, please. And if you could play the demo. Yeah, thank you. So previously, benchmark results were visualized in the way you can see now on the screen, and it was really hard to comprehend what's going on. The tooltip would make the situation even worse by displaying coordinates and no useful information. Next slide, please. And here also. Okay. The new version starts with being more colorful. Consequently, the borders between the cells can be seen better now. When hovering on the cell, users can see the tooltip with the findings from corresponding paper for which epistemic parity was calculated. If users still needs more information, they can click on cell and the whole paper and its correct page will be displayed under the histogram. Next slide, please.
And about the work in progress and the future tasks, right now we want to add transformers for the ID interface so that it will allow us to transform the data before synthesis in different ways, and also expanding our documentation website with more examples on how to work with the Synergy package, for example, how to add a new paper or a new synthesizer, or how to use transformers and many more.
One more task that we are still working on is to extend benchmark with more synthesizers, for example, GCD synthesizer. We also want to improve UI and UX for the benchmark result by providing more controls for the layout and displayed information. The last but not least, we started working on the demo proposal for Sigmoid 2024 conference. That's it. Thank you. And if you have any questions, just ask them.
Thank you so much. We have time for the questions.
I have one question. So I saw your example how you have initial data set, you use your Synergy library, and you get like more data set with each is more differential, private probably. And I noticed that for such column which is name, you just completely hide values or just remove that column. And for me, it's interesting, like how do you remove such sensitive columns? Because like sensitive names can be different. They can be not only name or address. It can be like location, country, and so on. Also, some financial information can be like sensitive information for me.
Yeah.
It's interesting how, yeah. So.
Okay, so basically the package itself, it's a benchmark, as we said, and it measures the this value of epistemic parity for the findings, and the findings are not related to sensitive columns. So when we are creating this differentially private data set, we are using only sub-data of the whole data set, which is not including the sensitive information because the findings are not including the sensitive information.
Okay, thanks.
Great. Let's have a break for 5 minutes and we'll come back.
Thankful for that chance, as it was cool and interesting experience in a new field for me. Due to some circumstances, I would be presented by myself.
I'm very sorry, Vladislav, I forgot to restart recording. Could you just restart?
Okay.
Very sorry, thank you.
Okay. I will tell about projects in the forest despite the trees. For last semester, I was working with mentors from New Jersey Institute of Technology, Arita and Kaustau, and I'm thankful for that chance, as it was cool to have that experience. I will start with outline of, next slide, please. I will start with outline of our task that we face during work. Now, every day, we get new and new data sets that become open source for people from the whole world. And often the data is real, but anonymized. In relation to one data set, everything is okay, as we can get new information from one data set. But we can find new data if we combine data set with the other one. On the example, we have some values of critical attributes in both data sets that we can find intersection of those data sets by those columns and find information about certain person that we couldn't find before. This is a bad situation, and we have to know that some data sets may give that information to us. Thus, we have to create metrics for that. Next slide, please. In fact, my mentors suggested a solution for it in their published paper. That is value framework for visual analysis of data sets and their paired utilities. It is already ready to use, and it gives various tools for a person to inspect set of datasets, and our task was to further improve that. Let's first, next slide, please. Let's first understand what is a utility score. It is a weighted sum of 3 ratios, and each of those ratios contains different relation between dataset A and dataset B. Some of those finds similarity in columns of datasets. Some of them find similarity in real values of those columns. And that score is the main metric to compare pairs of dataset. And pair of datasets with higher utility score are usually more worse because they can show more information about a person. Next slide, please. At first, I looked into our utility score and found out that our current distribution is not the best for comparison, as we have plateau, and it is very bad for comparison of dataset pairs. Next slide. Thus, after looking into code of calculating utility score, I found out a moment that can improve our distribution of utility score. So after some changes, we can see that our distribution changed and we got rid of that plateau, and most of the points have a very unique score, which is good for us because now we can compare them and find much more interesting datasets for us and get rid of those that are not that interesting for us. Next slide. Except changing the code, also I looked down into parameters that were used into that code. In fact, I was changing them and looking at how it changes the behavior of our code. So we can see at both graphs. On the left, we have results of our utility score, and on the right, we have execution time of our utility score. In fact, with improve of cutoff lengths, in fact, which means number of entries that we compare between each other, we can find that with improve of cutoff lengths, we can find much better results, but we have much higher execution time. So we, in fact, had to find some optimal cutoff lengths for that, because we can't run for eternity. So we had to find something optimal. Next slide, please. Except that, as I mentioned before, utility score is a weighted sum, and I also looked down to different distribution of those weights. In fact, it resulted in peak of weights that would point out more vulnerable datasets pair, while not vulnerable pairs would have lower utility score. Thus, we can only focus on most interesting ones and get rid of those that are not interesting for us. Next slide, please. Also, there are some future steps for us to make, and most of them is meant to improve our execution time. And also, there is introduction of new algorithms for specific column types, because numeric types and text types are very different in comparison. And that is all from me now. Thank you, and you can ask if you have any questions.
Thank you, Vladislav. I have a question. So maybe I missed this. What were the data sets on which you tried this?
Our mentors already had datasets. There were like 400 of those, and we were creating each dataset had a pair with every other dataset. So we had like 70,000 of pairs of datasets, and we were running our algorithm on them.
And you tried it on all of these dataset pairs?
Can you repeat that?
Square. You did your analysis.
My internet connection is not
400 square.
I think it's from Julia's side.
Yeah, we can't hear Julia well.
Can you type in chat maybe, because
yeah, I'm fine. Thank you. You answered my question. That's fine. Thank you. I was just asking whether you did it on all of these many data sets and all of these pairs. That seems impressive.
Thank you.
Can we start? Yeah. So,
Sure.
Okay. Hi everyone. We would like to present you our project we've been working on our semester with Katya, Sharp, explaining ranking and preferences. As our mentors, Venetia, Joao, and Julia were helping us, and we are very thankful them for their help. Next slide, please. So, automated rankers are widely used nowadays, and as a response, a lot of methods to explain them arose. As a result, a new problem appeared. Which one of them is better to use for our reasons? So our project's final goal is to create some viable, suitable benchmark to compare these methods. For this reason, in this project, we focused on these three methods to explain the rankable AI, and we ran them on the following dataset. Next slide, please. And now we'll focus on each method of the methods more deeply. So the first method is Sharp. The main idea of this method is to adapt Shapley values to the ranking systems and to represent the contribution of each feature to the final score. The second method is nutritional labels, and the idea of it is to come up with some tabular data similar to nutritional data placed on the every product in the supermarket, like what are ingredients in this score and what the contribution of each ingredient is.
The third method that we focused on, sorry, the previous slide. Thanks. So the third method that we focused on was sensitivity analysis of random datasets developed by Yuan and Dasgupta. The main idea of their work was to develop an app where a user, by generating synthetic data, could observe the differences in contribution of features to rankings. The data was ranked consisted of two groups, privileged and protected, with two attributes in each. The user could enter the distribution parameters for each attribute. Then the contributions were evaluated using three types of Shapley values and displayed on plots in the app. In our case, we have modified the code for calculation of Shapley values to be able to run it on any dataset. Also, for our further discussions and our further work, we will have two more methods. First one is participation metrics, where transparent participation metrics are proposed, which evaluate contribution of individual parameters. And the second one is local neighborhoods explanation, which uses the explanation of features, not on all the data sets, but using the neighborhood of the point that we want, features for which we want to describe and explain. As the next slide, please. Also, the important thing is on which datasets we run these methods. So the main dataset for this project was ATP players dataset. It contained a lot of information about male tennis players in years 2020 till 2023. It had info about different scores of these players, and it had 4 protected attributes. These were age, height, weight, and nationality. We did a lot of preprocessing, and also this dataset is publicly available on Zenodo. The second dataset was CS rankings, and it had some info about different colleges and the number of applications and faculty members and so on for this college. Also, for further discussions, we have 2 more datasets about the football players and about universities, so we can use it in the future. Next slide, please.
So, and now the results about what have we received learning each method. Tanya, can you please switch the slide? Yeah, and here you can see the results of the SHARP method for the tennis dataset. And on the right, you can see the contribution of each metric to the overall ranking and score for each bucket, less than 10%, 10 to 20%, and so on. And also it can show the contribution of each feature to the individual point. And on the next slide, we can see the tabular data for the nutrition labels that shows the main ingredients that are most important one for the resulting score and some interesting metrics about it. Next slide, please.
So here we can see the results for sensitivity analysis method. These ones are the results for ATP dataset. So we can see how different features contributed to rankings. And also the important thing is that in this case, for example, weight, height, and age haven't contributed to ranking. And on the next slide, we can see the results for CS rankings. So here we had only 3 features that were included in scoring function, and in this case, the faculty number of faculty members in this institution played the most role in this ranking. Next slide, please.
Yeah, and talking about the future, we are planning to run our methods for to new discuss earlier dataset, and also explore more methods that were also discussed earlier, and also approach our ultimate goal of the project to somehow compare these methods on all these datasets. Thank you for your attention. We If you have any question, please.
Any questions?
Well, I'd like to ask a question, if I might. So what is the idea behind comparing the metrics? I mean, given that they're, in essence, different metrics and they capture different ideas, I guess, how would you compare those?
How to compare different explanations is a nice question, and that will be for further discussion, because now we have just explored how different people approach this question of actually explaining any rankings, and that is already very questionable and debatable. So that is another very great question, how to compare that. So that will be discovered in our further work.
Gotcha. Thank you.
If I may chime in very quickly, this is a really, really important question, right? And this is something that you get asked by reviewers a lot. Why didn't you compare to another method? And they always expect you to give a quantitative comparison, but in this case, that's not just gonna really work. So we need to compare qualitatively more than anything. Just what does one method capture versus another? What user studies and similar.
Great. Move on.
So I'll start. Our assigned team consists of 4 members. To enhance our efficiency, we have to split our team into sub-teams. Each team will present their respective tasks, and we will start by discussing the work completed by our Omnist Ed team. Next slide.
Yes, learning with constraints is a unique approach in machine learning that involves using specific rules or guidelines during the training process. This method is particularly effective when dealing with complex or insufficiently defined data. It ensures that the learning model sticks to predefined constraints, thus aligning its prediction with real-world expectation or theoretical principles. Our research employs this approach in the Omnist problem. The model predicts the sum of 2-digit images from the Omnist dataset. The twist in our methodology was not to predict the sum directly, but to identify the pair of input images that result in the sum. The constraint here was unique. The model was trained without specifying the exact input pair, but by considering all pairs that could potentially yield to the same sum. This approach challenges the model to understand not just the arithmetic operation, but also the underlying pattern recognition. Next slide, please.
So in our investigation, we focused on various loss functions that significantly influence the model's learning process. We explored several types of loss functions, like presented negative log likelihood loss, commonly used in classification tasks. This loss function just measures the difference between the predicted probability distribution and the actual distribution of the classes. Then uniform loss, this simple yet effective function is used when multiple outcomes are acceptable. Then meritocratic loss is a sophisticated function smoothly that transitions between the NNN loss and uniform loss. The key parameter here controls the interpolation between these two functions. Then leverage weighted loss is crucial for tasks requiring a distinction between allowed and disallowed outputs. Then risk-consistent loss is an identification-based function that is used in partial label learning and incorporates a unique weighting mechanism. Then liberal loss, balanced loss function, designed for scenarios involving partial label learning. And Sagittarius loss, created for partial label learning and balances the treatment of both acceptable and unacceptable outputs. And unique one, pylon loss, is a narrow symbolic training framework that integrates neural networks with specified knowledge. It enables the specification of constraints as the PyTorch functions, compile them into loss. Next slide.
The initial task of predicting sums proved to be relatively straightforward for the model. To conduct a more accurate evaluation of the loss function, we introduced more complex arithmetic operations involving 3 input images rather than 2, and various functions like multiplication, division, modulus, and their combinations. This increased the complexity of the task and provided a better comparison of the effectiveness of different loss functions. Next slide, please. Further escalating the challenge, we shifted from the MNIST dataset to the fashion MNIST dataset. This change meant the model had to adapt to a more complex set of images. Each closing item represented a digit. This not only increased the difficulty level, but also showcased the robustness and adaptivity of our model under the guidance of constraint-based loss functions. Next slide, please.
And to add another layer of complexity, we experimented with noisy labels. This involved using different arithmetic functions such as sum, product, models, etc., to label different input pairs randomly, creating challenging scenarios for the model to navigate. For now, we have got quite unexpected loss behavior, so we are planning to continue this investigation. Next slide.
Yes, hi everyone. Our team has been working on a project based on the RAID challenge that stands for the RAID event detection with requirements. And for those who are interested, there is a link on the slide. But in general, the organizers provided the participants with an open data set that consists of 22 videos, each 8 minutes long, alongside with a list of specific requirements that reflect basic like commonly understood facts. For example, the traffic light cannot be both green and red at the same time, and also 41 specific labels to predict for action, agents, and location. And the main goal of the challenge is to identify the object on the video and categorize them using multi-label classification. But what is important is that this categorization must adhere with the provided requirements. So next slide.
So the RAID challenge actually consisted of 2 tasks, and in each task we had to exploit the given requirements. They were represented in the form of Boolean operations. For example, the requirement not move away or not move forward meant that an agent cannot move away and towards the vehicle at the same time. As for the parts of the challenge, the aim of the first task was to develop the best performing model with only a subset of annotated data, which was 3 videos out of 18, and to make use of the constraints on the unlabeled data. The desired output was the bounding box, which is basically the coordinates for a rectangular, which is drawn around our object of interest, and the set of and the probability distribution of the predicted labels. The second task involved developing a model that produced predictions that are all compliant with all the requirements, which is obviously a crucial thing for the field of responsible AI, as we do not want our models to violate any kind of logical constraints. The output was also the bounding box along with the predicted labels. In our approach, we used the baseline model to get the bounding boxes for each of the frames in the video, and Anastasia will tell you more about the actual algorithm that we came up with. Next slide, please.
Yeah, so in our training pipeline for the project, we incorporated both unsupervised and supervised methods. And for the unsupervised part, we use models which consist of 2 parts. The first model is just a general CNN model, and the second one was utilized for both training and evaluation. And for the training, we employed our sampling method. So we took our image and the vector filled with zeros as our input, and each next output of the model 2, which is seen on the slide, is represent our next label for our sampled vector. So to create a full labeled vector, which is our sampled vector, we repeated this process for the number of labels we have. So in general, we got our sampled method, which represented our labels. And to compute our loss and evaluate our model, we check whether the sampled vector satisfy our constraints. And with that information, we were updating our model. So the next slide. For the supervised part, we did almost the same, but we were comparing the sampled vector not with the fact whether it satisfies our constraints or not, but with our true labels for the images for the bounding box. Next slide, please.
So now our results. So first, we developed our own unsupervised and supervised, as we said, algorithm using a sampling-based approach to constraint loss. And we built the model, which made use of building conditional probability tree over the possible propositions.
We also had a chance to test our model with one of the losses that the MNIST-Ed team used, which was NLL loss in particular, and we saw clear results of the model workability. Apart from that, we reproduced the results of the baseline model and the model from one of the competition winners in order to be able to compare the results of our model with a reasonable competitor in the future. Next slide, please. So what are our future plans? Firstly, we would like to evaluate our algorithm against the results of, as we said, the baseline model and other competitors in order to assess the performance of our model in a representable way. We would also like to use other loss functions proposed by the MNIST-Ed team in order to assess how they influence the performance of the model. And finally, in case the next iteration of the ROTA-R challenge is available, we would like to maybe participate in this competition. Thank you for your attention.
Thank you. Any questions? Thank you again. Let's move forward. Okay, so the next project is our project, and I will start. Our project is about education dataset about ZNO, as we call it in Ukraine. And first of all, I would like to thank you, our fantastic mentors, Andrew, Paula, and Julia, and for my great team, Nazari and Sandra. Just a few words about our datasets that we now analyze. It's about external independent evaluation, the primary aim of which is just to ensure individuals' rights for equal access to higher education, and it's actually provided in Ukraine since 2008, and we have open data from 2016, so for almost 8 years in a row, and we have information, full information about more than for almost 2.5 million participants during 3 different periods about, we called it normal life, COVID, and the war. And we have a lot of nice information, actually sensitive about gender, about age, about location, test scores, test center, etc. But we don't have nice research about it, and one of the problem, I guess, it's because it contains a lot of mistakes, making it impossible to analyze across the years, and these mistakes connected to different parts. First of all, with names of locations and schools, because they are not normalized, because we had a few processes of renaming locations, and that's why they're renaming the schools because of decommunization processes and decentralization. And actually, in general, each year they use a different approach for the creation data set, and that's why we have some obstacles, some challenges how to combine all of them. And so we pre-processed this data, spent a lot of time, and Nazar will tell about this, and we plan to provide some suggestions to our center of who provides this evaluation, how to structure the data for the future analysis.
Hey everyone, I want to continue and tell about the processing. As Tanya mentions, a lot of issue we have in this data set. So first of all, we need to create some AR diagram which help us to normalize our data sets because it's too big, and have it in a database. And also it helps us to solve a lot of issue. Tanya, can you to the next slide? And yeah, from the issue, first of all, which we have, it's we need to unify features by year, because, for example, one test of Ukrainian language can be named different in different years, but it should be in one column, or another one. It can be that we have in some features different entities, a bit different text, but it's the same context, and we need to normalize it too by year. Next one, it is that we have lots of issue with naming of locations, naming of schools and test centers. Why it happens? It happens because it's like an open field, and people can write their informations like manually. And we have like two stages of fixing all of this stuff. First one is that we need to, we have like an automated parsing from different sites and databases which we find to solve these problems. And also we have like a big amount which we cannot solve automatically, and we need to fix and finding these locations somewhere. And next one, yeah. And the last part, what we did, we like normalized our data sets, and after that we can like create a database in a Postgres. We first start with a MySQL, but it cannot work with so big amount of data, and we move it to the Postgres and have a data set which is easy to work with them. And now we have this database and can work with it, and my colleagues will tell more about it.
So we just started our stage of the analysis, and we work toward different directions. One of the direction is just to explore migration inside this data set, because we have three types of the information. It's the location of the participant, location of the test center, and location if in case of graduates, the location of their educational organization. So we can see what's happened during this year. And for example, in this visualization, you can see that some regions just disappear completely because they were occupied, and that's why we don't have any participants from that regions. And some regions are not so bright. It's just because we lost almost 100,000 participants from 2021 to 2022. It just reminds us participants of this test, it's people who want to study at the university, so to get higher education in Ukraine. Another direction is just to take a look inside the test scores, and for example, we can take like different research. For example, just 10 days ago, we got the new results from PISA, and try to replicate these results, try to find the same findings inside this data set. For example, in 2018, like we knew that in Ukraine girls outperform boys in reading, and that girls score similar to boys in mathematics. And if you take a look inside our data set, we see like almost the same findings. For example, we see that in the Ukrainian test set includes the Ukrainian literature, we have like better results for female, and almost the same result for mathematics, and quite better like results for females for history. Okay, Sandra, you continue.
Yeah, I will continue with the analysis. So with this set, we can make different investigations into students' performance, for example, by analyzing different test statuses, one of which was failure status. So we can see this here is failure rates divided by gender in math and history test. And we can see that the girls perform a little better than boys on math test, and for history, this difference is even higher, which confirms what we saw in the previous slides too. But that's actually not the only insight which we can get from this graphic. Note that in 2022, the failure rate is minimum, with a literal high number in 2023. That's because the test threshold was set in a very, very low level this year to allow almost all students join the universities. And so we see that in 2021, failure rate is much higher for math. That's because 2021 math was made obligatory for one of the fields, for medical field, and it was really last moment decision. Students didn't have time to prepare, and it resulted in lots of failings. So even from this one graphic, we can have a lot of insights and ideas from this data. Next slide, please. Yeah, so having done the main part of the work related to the preparation of the data set, now we plan to concentrate on the part related to the research and analysis itself. In particular, we are analyzing literature and studies related to COVID and war impact on the educational process in Ukraine. And all the studies are operating on different data and study samples, so comparing them with the results of our study can provide us with additional level of insight. Also, we continue to work on the analysis, and we plan to focus on such aspects as migration, as we said, the gender gap, and the difference in performance between urban and rural children. With all this, we are going to write the paper and submit it to the PNAS, which is Proceedings of the National Academy of Sciences. So that's pretty it. Thank you, and we will answer your questions.
Don't have questions.
Thank you very much.
Don't have time for the questions.
No time for questions, but we can maybe leave some time for Q&A.
Yeah. Thank you.
Tom, I actually got a question, but I guess I'll just present.
Well, if it's very quick, like 30 seconds.
Yeah, that's like a second question. Wasn't there a difference, I think, in 2022 in the way they conduct the test? Or like, haven't they switched to this national multi-subject test format?
Yeah.
Are you like conflating two of those things, or do you have like a separate division because they're created differently? I think in their essence.
Yeah, for sure. We switched to different tests that before was paper based and now it's computer based, and it's as Sandra told us that it's much easier. We will draw and put in the analysis this information and of course to write about this.
I'm sorry again, being like, how do we compare different things? I guess it's just something that bothers me. Yeah, never mind. Thanks.
No, it's okay. It's okay. We understand that it's really hard to compare really different things, but we will try. Okay.
Anyways, yeah. Let me move to my next step. So, hi everyone. My name is Boris. I was working with Laura and all the other project mentors on the social media content analysis paper. Next slide, please. And I guess welcome to this 5-minute project walkthrough presentation. Next slide. I would like to just outline the general structure of presentation quickly. So I would quickly cover just the general context of what we're doing, then give you out some facts and some data insight that we got out of it. Then cover predicting popular posts and describe the future steps that we would try to succeed in. Next slide. So kind of giving out the general idea of what we're doing is that we have a really thorough data set of Facebook posts, giving you the text of the post, the images, if there are any, and stuff like that. And we try to explore Facebook news ecosystems quantitatively, meaning that we look at post engagement, which in this context means likes, comments, and shares, because it is a proxy of how many people see the content of Facebook and how much impact it has on people and on community of those platforms. And since we're coming from responsible AI and previous background in content moderation, we're trying to apply this to understanding what this means for content moderation and for platform safety in general. Next slide. I'm not going to post on the data collection stuff because I've spent, I think, 2 previous presentations hating the CrowdTangle API and the way we've been working on with the data. So I would just like to thank here our data engineering team for helping us to put all this stuff together. And here you can see quick stats for how many posts and how many pages for different ecosystems we have in our data set. So it's like 3.1 million posts total, which is a significant number in a sense. Next slide. Now get into the data insights. For everyone who knows what learned curves are, the Gini coefficient for engagement of posts is 0.93. For everyone who has no idea what this means a really unequal distribution of engagement in posts. And basically posts in top 1% generate 60% of engagement in our data set. Next slide. Which in terms means that there are a lot of posts that get no engagement. There are a vast majority of posts that barely get 100 engagements, means 100 likes and like some amount of comments and shares. And next slide, which means that we can just focus for the sake of presenting this stuff at the top 1% of posts. Next slide and next slide. Thanks. So there are a couple of interesting things for those top 1% of posts that we can look into. First, they have a longer lifespan, which means that they continue to generate their engagement. And so people continue to see them for longer, for much longer, actually, than posts from other quartiles. And next slide. And they also get much more engagement by definition, in a sense. Next slide. Then the logical question is, if we're trying to consider all the popular posts and how that influences our ecosystem, what makes content popular? Next slide. The answer is we don't know exactly, but we can do a correlation test, and we see median correlation with the number of subscribers the posting page has, and we see also a weak correlation with page verification status, which means that it's either a legit like Facebook official page or unverified one. Next one. Having this, we can now move to, of course, making a machine learning model, a fitted Boosting classifier, predicting the outcomes for the posts being in either lower quartiles or being in that top 1% that we're looking at. And we evaluate this, and this is where the metric stuff comes in. We evaluate ourselves by absolute engagement. It's going to come in the next hour, and we get 90% of total correct engagement classes, right? So this is good. Next slide, and next slide. And the final question is, well, what comes next? We're finally targeting the conference being using Security 24 and deadline for early February. So fingers crossed, everything goes good for this. And we have to solve a couple of minor issues and to slightly expand on the modern stuff. And next slide is for Q&A. Thank you.
Thank you. Any questions?
Actually, I have a question.
Great.
It's interesting topic, but my question is whether you thought about filtering some posts which have some artificial like propaganda-based increment in engagement, right? There can be like bots and other stuff that can increase this engagement artificially. Did you filter out such posts from the database, from the data set, or what did you do with it?
This is a great question. We haven't explicitly looked at the content of the posts. We do have, for at least the US data sets, some additional fields that come from external, again, data sets about like news pages and their political affiliations, and them being either more into misinformation or less, as fact-checked by external fact-checkers. We do not have that for Ukrainian and Russian data sets, unfortunately. We do filter posts by the engagement time steps they get, so just for the sake of data robustness, but we don't do any explicit like content filtering. Yeah. We had taken a look at what was being removed from the platforms, and we see the usual like misinformation and spam stuff removed. So there's nothing spectacular in the sense that there's no extreme stuff removed. So yeah, we're trying to focus on the ecosystem in general in this sense.
Okay, thank you. And you also mentioned that you achieved, like, for classification problem, 90% of engagement.
Engagement classes step, yeah.
Yeah. Have you cross-validated this number, or what was the strategy, how you defined it? Because as I know, based on the competitions, random forests or something boosting models, they are overfitting the data most of the time, and it's need to be like tackled some way. How did you approach the measurements?
Right now we're doing it in a basic train test split. We're planning to have a separate holdout data set and to replay the model on it to see how well it performs for the unseen posts when they are being generated in quote-unquote real time, because we're trying to predict future engagement, and there is a question of when the post gets posted and stuff. But yeah.
Okay, thank you.
Thanks.
Okay, thank you so much. Let's move for the last presentation for today.
Yeah, hello everyone. My name is Sophia, and together with my colleague Daniel, we worked on explainable exploratory data analysis. We are highly grateful to our mentors, Sihim and Silvio, for their help. And also for the last 3 months, we have worked on the Galaxy dataset, and we want to immerse you into the space atmosphere. So please, the next slide. Data exploration is an iterative and really challenging process. It involves executing a series of queries on a large datasets. Guidance in the exploration allows one to gain more insight into data analysis. It is usually provided through query recommendation indicating the following query to run on the data. Please, next slide. Reinforcement learning naturally applies to EDA to train an exploratory policy to find a target set. Reinforcement learning is a machine learning method that rewards an engine that perceives and interprets its environment, takes actions, and learns through trial and error. Please, next slide. The application of a trained error policy on a dataset produces a pipeline in the form of sequence of operators. This is an example, current pipeline step 10, of a 10-step pipeline generated with 4 operators. 2 of them are standard drill down and roll up operation on a dataset, and the other 2 explore similar sets or nearest neighbors. Please, next slide. The goal of Xera is to guide users by producing a data exploration pipeline where each step is annotated with an explanation in natural language. An example of guidance is on the slide. By choosing the bifacet operator, next, a scatter set can be reached within 2 steps by using a combination of bifacet and bineighbors operators on the attributes U and petrorad R for an expected final familiarity of 0.81. The word is given to my colleague Daniel.
Hello everyone. Let me introduce the architecture and implementation of the Xera system. Offline pipeline annotation takes as an input an arbitrary data set, extracts target sets, trains RL policies that locate the target sets, generates EDA pipelines, and annotates each step in the EDA pipelines. Next slide, please. Offline embeddings generation and explanation training admits annotated pipelines from the previous step and maps each pipeline into an embedding. To do that, it uses either a pre-trained model or trained sequence-to-vector model and stores the obtained vector representations in a database. We employed the OpenAI embeddings API as a pre-trained model, and as a vector storage, we configured and deployed ChromaDB. At last, during the online phase, a user interacts with the EDA UI, and with each interaction, the Xera system generates partial annotations for a pipeline while the user interacts with the data. The partially annotated pipelines are mapped to embeddings using either a pre-trained model or a trained sequence-to-vector model. And after that, we search for the nearest EDA pipelines in the embedding space and apply natural language summarization. And as a result, the user receives a guidance message summarizing the probabilities of the remaining operators to be applied to achieve a certain length of the exploration pipeline and predicts the most probable operator to be applied to the pipeline. Next slide. To implement the Xera offline data processing system, we employed Dexter, a cloud-native data orchestrator that provides a web UI including monitoring and observability of the data pipelines. Next slide. Xera introduces extensible annotations in an exploration pipeline. Xera implements 2 approaches for handling embeddings from annotations, one based on a pre-trained model and another on trained sequence-to-vector model. It predicts the next operator and explains and guides users by relying on embedding search and summarization to produce natural language explanations. Next slide. What we are finishing right now. First of all, we need to adjust the data pipeline to fit different explanation objectives. And we generate a larger data set of embeddings with EDA pipelines, which are employed to train a robust sequence-to-vector model. We have a hypothesis that our model will perform better to generate meaningful embeddings, and it will improve user guidance experience. Next slide. Besides, we have a few plans for the near future. First of all, we would like to derive metrics to evaluate the effectiveness of the explanations and compare the pre-trained and the trained sequence-to-vector models. Secondly, we would like to integrate a feedback system. Moreover, we would like to introduce and try other models and make some benchmark evaluations to derive the SOTA in explanations and guidance. Next slide. Thank you for listening, and we will be glad to answer any of your questions.
Any questions?
So I saw that there is a screenshot of a paper there. Is that your report, or is there an actual paper you're preparing to submit somewhere?
Yeah, on previous slides, it's a demo paper that we have already submitted to EDBT ICBT conference, and also we want to apply for 2 more later.
Nice, very nice. Any other questions from anyone? Okay, so let's attempt to take another photo. Please turn on your cameras. Thank you very much. And after this, we will do a brief Q&A, just generally. And I also promised that I'll say a few words about the next steps. All right, ready or not? I'm taking a screenshot. And one more. Moment. One more. 1, 2, 3. Okay, good. So as far as the next steps, first of all, congratulations, everybody. This has been an excellent. It's all in work and then a lot of work throughout the semester, but also towards the end to get the presentations ready. I'm looking forward to receiving your project reports. The deadline for that is Monday. And once your project reports are in, also as you are submitting them, there is a space on the form for you to say whether you would like to continue working on your current project and what the next steps might be, right, that you should put in your report as well. And also for the mentors, we're asking them to assess you. Once we have all of your feedback and once we have all of your reports, we will read the reports carefully and we'll speak with your mentors and we'll then get back to you within a couple of weeks, I hope. So expect this, I would say, the first week of January. Working with you, that we will be able to accommodate everybody's preferences. So who's done well, who wants to continue, should be able to join the program, but we will confirm this once all the reports are in. Are there any questions for me about the logistics, first of all? All good? So I'll send, or Tanya, maybe you can help with this, send a follow-up email just to remind people what the link is for the project report submissions.
And in this form, we don't have the space where they put, would they like to continue? So please put in your report exactly, like in PDF.
I thought there was, but yeah, it's good to put it in your report, and I'll edit the form to just add that field there.
Or maybe update the form. It would be nice, like to have this separate question.
I was also wondering if you could make the second team member as like a as an optional field, because
yeah, that's right. Yeah. Because we have some single team. Yeah. Okay. So Tanya and I will look at the form once again, right after this meeting. But in any case, we're expecting your reports by the end of the day on Monday. And thank you, everybody. Let's give ourselves a hand here. Excellent work.
I want to thank Julia and Tatiana for organizing this. It's massive amounts of work. It's a fantastic program.
Thank you very much, Michael. And thank you to all the mentors. You and the students are the people who actually make this happen, right? So thank you very much. And happy holidays to everybody. And be safe and well, and we will hopefully see each other soon. All right.
Bye.
Bye-bye.
Thank you. Thank you.
Thank you.